Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 6.5, which is going to talk about comparing properties of linear functions. Now, before we get into today's lesson, I just want to note that section 6.5 is the final section of Module 6, which, as you should know by now, that means that you have a quiz upcoming. So just something to be aware of. All right, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to compare properties of linear functions that are represented differently. So we're going to talk about comparing or identifying different properties of different types of linear functions when either you're given an equation or a table, or when you're given a description and a graph. And we're going to talk about how to compare different properties of these functions. All right, now before we get into our first example, there's two terms that I want to talk about. The first one is initial value. So the initial value is the point at which the function begins. It's the first output or the first y value in a given function. So just so you are aware. So anytime that we talk about the initial value, it's that first point. Now, the range is going to be the set of all output or the y values for a function. So if we're talking about range, remember range is the y values. So it's going to be the set of all possible y values for a function. All right, so with that said, let's go ahead and get into our first example for today. And example 1 is going to have us go through and compare the initial value in the range for each of the linear functions f of x and g of x. So example 1a, we have the domain of each function is the set of all real numbers, x, such that 5 is less than or equal to x and less than or equal to 8. So all of our x values are going to be from 5 to 8 for our function. The table shows some ordered pairs for f of x. So we have x as 5, 6, 7, and 8. And then the values for y, for our function of f of x, is 20, 24, 28, and 32. Now the function g of x is defined by the rule g of x equals 3x plus 7. So for f of x, they give us a table. For g of x, they give us a function. So they give us an equation. So when you get to the questions that are going to have you compare an equation and a table, you're going to do the following. So the first step, the initial value is the output that is paired with the least input. The least input, or the smallest x, for f of x and g of x is, well, if we go based off of this domain here, it's 5 is less than or equal to x and less than or equal to 8. The smallest number is going to be your number on the left, or 5, as represented by the table. So my least input for both of these is going to be 5. That means to find my initial value, we're going to plug 5 in for f of x and g of x. So the initial value of f of x is, what is the value of y when x is 5? So if we look at our table, when x is 5, our value is 20. So my initial value for f of x is 20. Now, my initial value for g of x, what we're going to do is take this 5 and we're going to plug it into the equation. So we're going to take this 3x plus 7 and it becomes 3 times 5 plus 7. So 3 times 5 is 15. 15 plus 7 is 22. So that means my initial value is going to be 22. So any time that you are asked to find the initial value figure out what your smallest number for x can be. Off the table it's 5, and based off of this domain it's 5. So when f of x, when x is 5, f of x is 20, so my initial value of f of x is 20. Then you take 5 and you plug it in for x into the equation to get your initial value of g of x. Alright, so that's how you identify the initial value. The next part is they want us to go through and identify the range of f of x and then the range of g of x. To identify the range of f of x, okay, we're going to look at our table. Okay, my smallest number here is 20, and my largest number is 32. So I take my initial value, my smallest number, that's the left side, so 20, and then my largest number is 32, so that's going to be the right side of my range. So my range of f of x is 20 is less than or equal to f of x, which is less than or equal to 32. So whenever you're asked to find the range based off the table, find your smallest number, your largest, and that's your range. Now for the range of g of x, okay, that's based off our equation. We've already plugged in our smallest value of x, which is 5. The next thing we need to do is plug in our largest number of x, which is 8. So we're going to do 3 times 8 plus 7. 3 times 8 gives me 24. And then 24 plus 7 gives me 31. So the range is going to be 22 and 31. So the range of g of x is 22 is less than or equal to g of x, which is less than or equal to 31. Again, to find the range of a function, you take the smallest number, you plug it in, and then that's the left side of your range. You take the largest number for x, plug it in, and that's the right side of your range. And that is how we do example 1a. Now, before we jump on to example 2, I want to do one more of these just to give us practice and another view of how to do these. All right, and I have to move that down. Okay, if we look at part B, for part B, it states the domain of each function is the set of all real numbers, x, such that 6 is less than or equal to x, which is less than or equal to 10. The table shows some ordered pairs for f of x, and the function of g of x is defined by the rule g of x equals 5x plus 11. So g of x is this 5x plus 11. F of x is the table. Now, the initial value is the output that is paired with the least input. The least input for f of x and g of x, if we look at our domain, the smallest number in this case is 6. So my least input is going to be 6. So if we look at the initial value of f of x, the initial value of f of x is the value of y when x equals 6. So if we go to the table, when x equals 6, my value of f of x is 36. Again, initial value from a table. When x equals 6, the value is 36. Now, to figure out the initial value of g of x from an equation, we're going to take that value of 6 and plug it in. So we're going to do 5 times 6 plus 11. 5 times 6 is 30. 30 plus 11 gives me 41. So my initial value of g of x is 41. Again, when you are finding the initial value of an equation, you're going to take your least input and you're going to plug it in. So 5 times 6 plus 11. Now, for my ranges, I can go ahead and put in my left side. because my initial values are going to start my ranges for f of x and g of x. To figure out the max for my range for f of x, my smallest number is 36, my largest number is 60. So that's going to give me my top parameter for the range based off the table. And then if we take a look based off the equation, the largest number in this domain is 10, so that means I need to plug 10 into my equation. So we're going to do 5 times 10 plus 11. 5 times 10 is 50, and then 50 plus 11 is 61. So that means my top parameter of g of x is going to be 61. Again, just to summarize, when you are asked to find the initial value, you're going to look at the least input, which is going to be given based off this domain. So from my inequality of my domain, my smallest number is 6. So to figure out my initial value off the table, when x equals 6, f of x equals 36. Based off the equation, you plug 6 in, and you get your number. Range for the table, smallest and largest numbers. Range for the equation, you're going to take the smallest number 6 and plug it in, take the largest number 10 and plug it in. And that is how you're going to do example 1 in terms of identifying or comparing the initial value and the range for both of these. Alright, so that is example 1. Now all we have left is example 2, where we're going to go through and talk about writing a rule for each function, then comparing domain, range, slope, and y-intercept. So that's going to be our part for example 2a. So example 2a wants us to do just that, where we have to write a rule for each of these functions, then compare their domain and range, their slope, and their y-intercept. So for A, we have a rainstorm in Austin lasts for 3.5 hours, during which time it rained for a steady rate of 4.5 millimeters per hour. The function a of t represents the amount of rain that fell in t hours. So if we're wanting to write a rule for the amount of rain in Austin, okay, we're going to take this 4.5 millimeters per hour, and that's going to help us go through and write our function for a of t. So the rule for a of t is going to be 4.5 t, because it rained 4.5 mm per hour. Now, there was nothing about starting out or initial amount, so we just start at 0, so it's just 4.5 t. There's no plus or minus number. Now, the graph shows the amount of rain that fell during the same rainstorm in Dallas, d of t, in millimeters, as a function of time t in hours. So the graph is going to give us our value or our function for Dallas. So we have to write a rule based off this graph. First thing we need to do is figure out our slope. To figure out our slope, we're going to do, remember it's y2 minus y1, so 20 minus 0 over x2 minus x1, so that's going to be 4 minus 0, which gives me a slope of 20 over 4, or 5. And then this crosses the y-axis at 0, so that means it's just plus or minus 0, or you can just leave that blank. So my function, or my rule, for d of t would be 5t. In Austin, it rained 4.5 millimeters per hour. In Dallas, it rained 5 millimeters per hour. So that is my rule for Austin and Dallas. Now, the question is, are my domains the same or different? So if we look at this, okay, we first need to identify our domain for Austin. In Austin, it rained for 3.5 hours. So it means we're going to start at 0 and it lasts for 3.5. If I look at my domain for Dallas, it started at 0 and it lasted for 4 hours. So, are these the same or different? They're different. Now, if we take a look at our range, okay, if we look at our range for Austin, the idea is that at the start of the rainstorm, there would be 0 millimeters of rainwater. So now we just had to figure out after the certain amount of hours how much it rained. So to figure that out for Austin, it rained for 3.5 hours and it was raining at a rate of 4.5. So it means we're going to take these two numbers and multiply them. So if we do 3.5 times 4.5, we end up with 15.75. So that's going to be the top parameter of my range for Austin. Again, how I found that out is I took the fact that it rained for 3.5 hours and I plugged that 3.5 into my rule. So all I had to do was just multiply those and I get 15.75. Now for Dallas, all we have to do is just look at the graph, and the maximum of our graph is at 20. So that means the top parameter of my range is going to be at 20. So, is the range the same or different? Okay, my ranges are different in this case because they both end at a different spot. Alright, now the last thing that we need to do is just compare the slopes and the y-intercepts of both of these rules. So the slope of A of t, is it steeper or less steep than the slope of D of t? So between these two numbers, is A of t, is this number smaller or larger than D of t? Is 4.5 bigger or smaller than 5? It's smaller, so that means that my graph of A of t is less steep, which relates to what we talked about yesterday. And then the y-intercept of A of t, is that greater or less than or the same? The y-intercept would be the plus or minus number at the end of these. Because there is no plus or minus number, that means that they are the same. And that is how we're going to go through and do example 2. So I gave you guys example 2 part A. I do want to go through and talk about example 2 part B. So that way you can see another example of this. Okay. For part B, our situation states that one group of hikers hiked at a steady rate of 6.5 kilometers per hour for 4 hours. The function f of t represents the distance that this group of hikers hiked in t hours. So f of t talks about this situation. They hiked for 6.5 kilometers per hour for 4 hours. If I'm wanting to write my function, okay, they hiked for 6.5 kilometers per hour. So my rule would be 6.5 t. Now the graph shows the distance a second group of hikers hiked, g of t in kilometers as a function of t in t hours. So that's going to be this line right here. So we have to write a rule for this line. We're just going to take the y and put it over the x. So it's going to be 36 over 4.5, which gives us 8. So that means my slope is 8. So that means they're hiking at a rate of 8 kilometers per hour. So that means my rule is 8t. So I now have my rule for both of these. Again, how I got the 6.5t is the one group is hiking at a rate of 6.5 kilometers per hour. The 4 hours just talks about how long. That doesn't have anything to do with how far they hiked. For g of t, my graph, because it starts at 0, these both are just minus 0. So it's just 36 divided by 4.5, y over x, and we got 8. So the next part is we need to go through and compare the domain and ranges. Well, for the first group, okay, they hiked for 4 hours. So that means they hiked from 0 to 4 hours. And then our second group hiked from 0 to 4.5 hours. So in this case, my domains are different. Now, if we look at the range, okay, for the first group, again, for the first and second group, they start at 0 kilometers. And then the first group, so they hike at 6.5 kilometers per hour for 4 hours. So we need to do 6.5 times 4. So if we do 6.5 times 4, we end up with 26. So they hiked 26 kilometers. And then if we look at the table or the graph, okay, this high water mark is 36. So that means they hiked 36 miles, or kilometers, sorry. So, are their ranges the same or different? They are in fact different for this. Again, how I figured out domains is, again, they're always going to start at 0 for both domain and range. So, how did I know to find 4? Is because the first group hiked for 4 hours. How did I know to put 4.5? Well, the furthest point on my graph is at 4.5 for the x values. For the range, we take the fact that they hiked for 6.5 kilometers for 4 hours, so we multiply these two numbers to get my 26, and then to get 36, we look at the graph, and it tops out at 36, so that's why I plugged 36 in there. Now, the last thing to do is to go through and use the slope and y-intercepts to compare if they're steeper, less steep, greater than, less than, or the same. So if we look at the slope of f of t, okay, does this graph, is it steeper or less steep than this graph? So 6.5, is it bigger or smaller than 8? Is 8 bigger or is 8 smaller? Okay, 8 is the bigger one, so 6.5 is smaller. That means the graph of f of t is less steep because 6.5 is smaller than 8. And then for the y-intercept of f of t, is it the same or is it greater than, less than, or the same as g of t? This is just plus 0, and this is plus 0, so that means they are the same. And that is how we do example 2. And that completes our notes for section 6.5 on comparing the initial values in the range when you're given an equation in a table, and then writing a rule comparing domain, range, slope, and y-intercept when you're given a description of a situation and you're given a graph of another situation. So that is it for today. That is it for our lesson on 6.5. Remember, 6.5 is the end of Module 6, meaning that you guys have a quiz upcoming soon. If you have any questions, as always, let me know via email or next time you see me. Again, I highly recommend you utilize my completed notes or reference the video as you work through the homework. And that is all that I have for you guys today. So thank you guys for listening. I hope you have a great day, and I'll talk to you guys later. All right, bye.